Welcome back. Ms. Killen here with MPB. So glad you came back to learn with us. We are still in our 6th unit of Introduction to Quadratics. Now we're in lesson 6, which is taking square roots to solve quadratics. We're looking at REI 4B. I can solve quadratics by taking the square root. And we did some of that in our last lesson, but we're going to get more involved here. So let's remember standard form. What is standard form? AX squared plus BX plus C equals 0. So when we see this equation, AX squared plus C, we know that we have some type of perfect squares and we're taking the square root. There are 2 steps that we follow. Set the variables on the left and the constants on the right. We take the square root of both sides of the equation. So let's take these steps, look at our examples. So our example is 4x squared minus 36 equals 0. So what are we doing? First thing that we're going to do is we're going to get our numbers on the right side. So I'm adding 36 on both sides. 4x squared equals 36. I'm isolating that variable by putting all my numbers over. So I have x squared equals what? 9. Now, you may stop here and say, okay, variables by itself, but is it? It's not. That x is not by itself. It has an exponent there. So I need to get rid of my exponent. How am I going to get rid of my exponent of 2? Take the square root. So let's go ahead and try that. I'm going to take the square root. Whatever you do to one side of the equation, you must do it to the other. So now x equals. Now, this is where we need to remember some key phrases and some key things about this. When I'm multiplying, positive times a positive is a positive. Negative times a negative is a positive. So when I take the square root of 9, I have to show that on my paper, that it could possibly be a positive and it could possibly be a negative. So let's see. The square root of 9 is plus or minus 3. It could have been a negative 3 squared, or it could have been a positive 3 squared. So you've got to remember when you're taking these square roots, you've got to show that positive or negative because it could be both of them. That was a good catch. Okay, so let's look at the next example that we have. It says, and up here by my little flower, positive times positive is positive, negative times negative is positive. So we've got to make sure that we're keeping that in mind when we're looking at these two. So let's go ahead and redo what we've done with this in mind. Ms. Killen, we've already done this problem, but I want us to make sure that we're understanding. We're going to redo it. So we've got where we added 36 on both sides. So we had that 4x squared equals 36. Then we divided. We saw that we did that, and we were left here. We've got to make sure that we take in consideration that that x is not by itself until that's all that's over there. There can't be any numbers, there can't be any exponents, there can't be any type of symbols except that x. Ms. Killen, why are you making such a big deal about this? Because in future lessons, we're going to have different types of exponents, different types of formulas that we're using. And so I'm wanting us now to build that foundation of when x is by itself, there's nothing else over there, no exponents or anything. So let's take that square root, which undoes, or it takes away that squared. So let's do this. Square root, x is by itself, and that positive or negative 3 that we talked about up here. Positive times positive is positive, negative times negative is positive, so I have to show that it could possibly be a positive or a negative. All right, so let's look at some more. Now we've got this one. 2y squared minus 36 equals 0. So I'm going to do the same thing and see what's going to go on. You can factor out from under the square root symbol. And when I'm factoring, I'm going to do some type of circling. So with these 2 notes in mind that we put on our notes page, I want to go ahead and do example 2, but I wanted to give those 2 notes first. So the first thing I'm going to do is get y by itself. To do that, I'm going to add 36 to both sides. So I've got 2y squared equals 36. Still got to get y by itself, so I'm dividing by 2. So y squared equals what? 18. Good job. Still getting that y by itself. So what are we going to do? You got it. Square root on both sides. Whatever you do to one side of the equation, you do to the other. So y equals what? Well, is 18 a perfect square? It's not. So Ms. Killen, what do? I just can't leave the square root of 18. You're right. So what we're going to do, where these two notes that we wrote down come in mind, I'm going to factor out from under that radical sign. Let me show you. I have the square root of 18. So I need to know the factors of 18. Well, that's 2 and 9. 2 is a prime number, but 9's not. And I have 3 and 3. Now, when I am taking the square root, I am undoing what was squared. So when I see a double, I'm going to circle it and bring it outside of that radical. Anything that I cannot circle, I put a box around, and that is an indicator that stays under the radical sign. So when I get my answer, it is plus or minus 3 square roots of 2. It says you circle your doubles and square what's left. The circles come out and the boxes stay under the radical sign or the root symbol. So when I took 2y squared minus 36 equals 0, factored it down, factored out from under the radical sign, my y equals plus or minus 3 square roots of 2. There's always a way to get these answered reduced or in lowest terms. We always want to make sure that we're looking at that. All right, so let's look what's next. Let's do some practice. Let's consider this one. Negative 5t squared plus 80 equals 0. So how are we going to work this one? Well, first thing I'm going to do is I'm going to see if there's any, what? You're right, GCF. So do I have a GCF? Maybe. What do you think? Yes. So I'm going to factor out a negative 5. Now when I factor out a negative times a negative would have given me a positive, so what am I left with? What is 80 divided by 5? 80 divided by 5 is what? 16. Now look what we have in our parentheses. T squared minus 16 is what? You're right. Perfect squares. So I have a t and a t, a plus 4, a minus 4. So now that it equals 0, I need to know to keep on going. So I make each one of these equal to 0. So I have negative 5 equals 0. There's no way. T plus 4 equals 0. Subtract 4. So t equals a negative 4. Then I can take t minus 4 equals 0. Opposite operation. T equals 4. So I can put this as t is a plus or a minus 4. And if I put those into my expression or my equation, it will make that expression true. Even though I took out a GCF, I still ended up with my answer. All right? Let's look at the next one. It says, solving the following quadratic equation results in what solution or solutions? So let's see. I've got 2x squared plus 17 equals 179. Well, it's the first thing we learned when we're solving these equations. Got to get everything together so I can see what I've got. So I'm going to use opposite operation and move this over here. And I'm going to rewrite it. 2x squared plus 17 minus 179. Now, Ms. Killen, I can put those together because they're like terms. All right, so I have 17 minus 179 is what? You're right. I'm left with 2x squared minus 162 equals 0. Now, same thing, I could take out a GCF, or I could just get x by itself. Let's just get x by itself and see if we get the same thing. May not, may too. Let's see what we got. So first thing I'm going to do is I'm just going to add this 62 back to isolate that variable. I'm going to divide by that 2 to isolate that variable. And what do I get? 162 divided by 2 gives me what? 81. So now I have x squared equals 81. Still don't have that x by itself, so what am I going to do? I'm going to take the square root. So I'm taking the square root of both sides, and my x equals plus or minus 9. So either way I do this, take out a GCF and work it that way, or just get that variable isolated and do it that way, I'm still coming to the same conclusion of my variable equals a plus or minus and then my number. So we got to make sure that there's multiple ways to do this, and which way is more comfortable for you may be the way that you need to work it. Now, we do need to know that sometimes on these different practice problems or on these test questions, they say use a specific way because they're going to ask you questions about the process. So that's why we have to learn all these different ways. All right, so let's look at some more problems. So now it's time for me to master this. So let's read our problem, and then I'm going to let you work. An engineering student is a participant in an egg dropping challenge. The main object is to create a vehicle for the egg to be dropped from 48 feet without it breaking or even cracking. The equation h equals negative 12t squared plus s can represent the object, where h is the ending height, t is the time in seconds, and s is the starting height. How long does it take the vehicle holding the egg to reach the ground? Create an equation, then solve. Go ahead and pause the video. Either you or you and your table partner work the video. You and your table partner work the equation. Make sure you're rereading your passage, and let's see what we got. So my question tells me to round to the nearest hundredth if necessary. So that may give us a clue. All right? So we've read the passage, we've gone back and looked at the math. Now let's see what Ms. Killen can do. Here we go. I have my equation, which is h equals negative 12t squared plus s. It tells me that my s was what? My starting height. Well, it tells me my starting height is 48. And then it says t in times, so I'm left with this. So create the equation, then solve it. So when I'm solving, I'm wanting to get to the ground. Ground is always going to be my 0. So here we go, negative 12t squared plus 48. I'm just going to isolate my t. That's how I'm going to work this one. Just isolate my t. So here we go. So I've got 0 equals negative 12t squared plus 48. I'm subtracting 48 on both sides. Negative 48 equals a negative 12t squared. Divide by that negative 12 squared. Negative divided by negative is a positive. 48 divided by 12 is what? 4 equals t squared. Since my t is not by itself yet, I'm going to take the square root to get it by itself. So t equals plus or minus 2. So there I have answered my question, either a positive or a negative 2. Good job. So then it also has number 2. I'm solving this. Again, rounding to the nearest hundred if necessary. So let's go ahead and try number 2. Here we go. Solve 6x squared minus 72 equals 42. Well, obviously, I need to get x by itself. So, Ms. Killen, what if I don't take everything to the left and then take everything to the right? What if I just started isolating at the very beginning? You can do that. Let's try it. So, let me get another color. Let's try this one. So, I have 6x squared minus 72 equals 42. So what if I just move that 72 over where I have 6x squared equals what? Nope, 14, Kimberly. Gotta put 114. There we go. So now, still going to divide by that 6. So x squared equals, when I have 114 divided by 6, I get 19. Still need to get that x by itself, so I'm going to take my square root. Now, Miss Killen, 19 is a prime number. I can't even factor anything out from under that radical sign. That's exactly right. So how am I going to put my answer? Glad you asked. You're going to put it like this. My x equals plus or minus the square root of 19. And that's how I answer it. Now, some questions are going to say, give us specific. Okay, so this one says, if necessary. Well, you could put square root of 19 in your calculator. Let's everybody put the square root of 19 in your calculator and see what we get. The square root of 19, we get a big long number. But this problem tells me how to write this big long number. X is approximately plus or minus 4.36 because I rounded it to the nearest hundredth, meaning 2 decimal places. All right, we got it? Okay, let's not forget. Always set variables on the left and the constant on the right. We want to make sure that we are taking the square root of both sides of the equation. I'm so glad that you came to learn here with us at MPB. I'm Miss Killen. I want you to have a great day.